Sunday?
Yeah, Sunday, sir. I'll be classes, sir.
Yeah, even I feel bad sometimes, but what to do? Most of the working professionals will get some time in Saturdays and Sundays only.
Yes, sir.
Okay. Nikhil,
Yes, sir.
you had a message in Discourse, man. How much you got? Are you above the mean or below the mean?
55.
Huh?
55, sir.
50.
55.
Okay. Your expectation is like 60, right? 60 or 70, you said.
No, sir, I was not expecting anything. I did not study for statics. I
Okay.
told you in last session I focused on maths, but I got less
Yeah.
mark.
Maths, huh? Yeah, even.
But I got less marks in maths, sir, than statistics.
Yeah. See, even maths was not that good, not up to the mark, and it was even worse than stats too.
Okay.
Okay, so today we are going to do week 11.
Sir,
Hmm.
that end term grading pattern has been changed, right?
Is it?
Yeah, for quiz 2 marks improvement, we got a mail that they will consider quiz 2 marks from end term also.
Quiz 2 marks from end term also. What is
Yeah.
that?
Like some question will come from quiz 2 syllabus, and that percentage, if that percentage will be more than our quiz 2 marks, quiz 2 percentage, then they will consider that percentage as a quiz 2 percentage.
Oh, sorry. Then I don't know. Maybe I should go and watch my mails back.
Yeah, actually, I was asking that it is for stats only, or it's for maths too.
For every course, I guess.
If it is
for all subjects of this term, for all courses of this term.
So
Okay.
what exactly is this? If your quiz 2 is bad, then your end term is good.
Yeah, then the percentage will considered as
on pro rata basis, sir. In I think in end term exam, sir, they will consider the pro rata marks of questions related to week 2. And on that basis, they will assign marks for week 2 again, and the max of week 2 will be taken for week 2. Sorry, quiz 2, not week 2. Quiz 2.
Yeah, understand.
Yes, sir. But this has been done only for once, I think, because of Bakrid festival. It was there on that.
Yeah.
What festival?
That paradox event.
Okay, paradox.
Bakrid. No, not paradox. Bakrid, on that day, on Sunday, Bakrid was there, some Muslim festival. Bakrid.
Okay, so you are referring to the recent one, quiz 2 date.
Yes.
Achha, okay. So many people haven't come to the exam because of Bakrid, is it?
That's what I also had. ऐसा होता नहीं है, हमेशा मत करना.
Okay. Anyway,
मतलब फेस्टिवल के लिए हम एग्जाम छोड़ने, पता चला फेल हो गए, 4 महीना लग गया फिर से.
हाँ, तो इस बार कंसीडर कर लिया, पता नहीं कैसे किया इन लोगों ने.
Okay.
The language was somewhat confusing. They said that they will consider max of pro rata or max of two and final. So we took a risk.
So let us concentrate on end term so that we can compensate quiz 2 also. Yes, sir.
Yeah. Okay. So we are going to do week 11 today.
Sir.
So how many of you have seen week 11? At least opened one of the lectures. Okay.
Sir, I did, sir, a couple of lectures actually. But yeah, I referred some outside videos also to understand this hypothesis and everything. So yeah, basic thing, nothing much. Yeah, but basic thing I just try to get actually.
Okay, maybe in my perspective, what I feel is the more enjoyable part in this particular stats to whole course is this particular weeks, week 11 and week 12. So in this particular weeks only you will get to know how actually in industries or wherever you have the data with you, or when someone says any statement, how will they justify their statement, how to justify that the guy said is true or false. That particular justification will be taught in this week 11 and week 12, which is nothing but the hypothesis testing. So
sir, how many weeks will be there, sir, now, sir? I mean,
this is week 11 and there is one more week, which
week
is
12.
week 12. Yeah.
There won't be any week 13, right?
No.
That is also on hypothesis, right, sir?
Yeah. Both the weeks are on hypothesis testing. So this is the last concept in this particular stacks 2 we are going to learn. So test of hypothesis, or very standard name called hypothesis testing. So in this today's lecture, we will try to cover this, what is hypothesis mainly, and what are null hypothesis, alternative hypothesis, and what exactly is an acceptance set, and how to define a test. So everything, or whatever the situation or whatever the scenario, in order to justify that particular statement said by you or said by someone, or in order to justify some well-known facts but you don't know whether it is true or false, everything need to be tested. So that particular testing we will do in this particular test. Depending upon the test, we will conclude something. So, and later we will see what is size and power of a test, and then we will get into types of hypothesis testing. So basically there are two types we are going to deal. One is simple and another one is called
Complex.
not complex. Oh shit, I forgot the name.
Composite.
Yeah,
Composite.
composite. Composite. Okay. So, and later we will see some standard tests. So testing of mean, testing of variance. So if one sample is given, these two. If two samples are given, we will test between two means and between two variances. And if there is time, I will cover this p-value. Okay. And these are the most important topics that were dealt in this particular week 11.
Yes, sir.
Okay. So before starting, what exactly is hypothesis? So what do you, when you hear this word called hypothesis, what actually comes in your mind?
Assumption.
Sir, excuse me, sir.
Yeah, one guy said assumption. Okay.
Sir, I was looking at this lecture, sir, 11.1, sir, the first example that sir was lecture 1, 11.1. I started going to that. So,
can you be a bit louder, Krishna?
Hello.
Yeah, now okay. Now
Is
can
it
you?
audible, sir?
Yeah, you are audible, but your voice is breaking in between. So if you speak loud.
Yeah. So, okay. How about now?
Okay.
So I was saying that I was going through this. I started off with first lecture, first video of week 11. So I was going to the example that I was doing, but few things are. So it's like I stopped even before starting. That's what I felt feeling. Point tossing example with conceptually, theoretically, I understood, but the example was given, I just lost the track.
Okay. We will deal. Today we will deal that. But my question is, what exactly comes in your mind when I say the word hypothesis? It's nothing related to statistics. Don't always compare with this particular
The
course.
hypothesis
Something
means,
real values, sir.
Sir, hypothesize means you are stating something as a fact.
As a fact. Okay.
So it has to be proved or disproved. That is the second
correct.
But
Okay. 90% agreed with you. So one side assumption, one side it's a fact, but it is not proven yet. And someone said it's a real
values, real scenario or
a real scenario. Okay. Any other input?
opinionated.
It's a point of view that's based on certain assumptions we make.
Correct. So hypothesis is basically an assumption for something. So for some situation or for any scenario, we make some assumption, and that assumption we make based on some known facts before. But that particular assumption is not been proved yet. So if it is not been proved yet and we make some assumption based on the very well-known facts, that particular scenario or that particular thing is called hypothesis. So for examples, so these are few examples you can see. If I replace battery of my vehicle, then it gives better mileage. So I haven't replaced it, but from the facts I know that from the past, so many of them, many of your colleagues or many of your neighbors might have replaced the vehicle's battery and they have seen better improvement in the mileage. And now what your hypothesis is, you are trying to replace your battery. Now you wanted to replace your battery of your vehicle, maybe car or bike. So once you replace your battery, your assumption is that it gives better mileage. Okay, and there is one more example, like if I eat more, then I can gain weight. I will gain weight. So this is also one. So from the well-known fact that if people eat more and they physically build weight, but not true for every case. So it's just the hypothesis. These kind of situations are called hypotheses. So these are not proven yet. Until and unless you gain weight, you can't even conclude whether you are gaining weight or decreasing your weight. Likewise, the third example is like if I study for 8 hours a day, then I can score good marks. So these are some hypotheses wherein you have to test this hypothesis and conclude whether it is true or false, or whether it is true or false. We conclude by testing. So we test the hypothesis and conclude. And why do we need this testing? So why to have an hypothesis?
To go to some conclusion, to reach some conclusion.
Yeah. So these are, so in our data science or as a data scientist, what we do, we actually take the past data and we predict the future. That is what we do, right? Predict the future data or anything. So these hypotheses will help us doing that particular thing better. Okay. So let us see one example before we proceed to null and hypothesis. What is null hypothesis and what is alternative hypothesis? There are two types of hypothesis which we are going to deal in this particular week. So suppose you have two coins which is one is unbiased coin and one is biased coin. So in the lecture, sir might have used authentic and counterfeit. So it's nothing but authentic is like some real coin or not the fake one. So it's a real coin and it is unbiased coin. So I use the words unbiased and biased. So you can correlate. So authentic means unbiased, counterfeit means biased. So treat it like that. When you watch the lecture, just correlate from there. So I have two coins with me. One is unbiased coin and one is biased coin. Unbiased coin has probability of heads as 0.5 and biased coin has probability of getting heads as 0.6. So 0.6 or 0.7, not 0.5. So I just took 0.6. And I don't know which coin I gave you. Suppose you have that coin with you, and which can be either biased or unbiased. You don't know which coin I gave you. Both look similar pretty much. And now what you have to do is you have to predict whether the coin is unbiased or biased. So what is the first and foremost step we do once if we are in this particular situation? So if your friend gave you one coin out of these two coins and asked you to predict whether this coin is unbiased or biased, so what will run in your mind at that particular moment?
चेक कर लेते हैं कैसा है. Test it out. To test it out by performance and experiment.
Yeah. How what is the testing? What test you do?
to toss the
See,
coin.
Experiment perform करके
some
toss करके
test
देखो.
toss and see how
Correct.
much whether I get it, and then
Correct,
they
correct,
equal.
correct. So what we do is actually, अगर हमारे पास, if we have that coin in our hand, what we do is we randomly toss the coin some multiple times and check how many times head is getting. So maybe you toss the coin 10 times and you have observed some 7 or 8 times head. Then you might think that coin is somewhat biased coin towards head. Correct?
Yes. Yes, sir.
Right? Out of 10 times I got 8 heads. And you know that this we know. Either one is out of these 2 coins, one is unbiased and one is biased. There are only 2 coins, and among those 2 coins we have been given 1 coin, and you started testing it by experimenting. So the testing. So what is the test here? We are tossing the coin few times, so maybe 10 times. So in order to satisfy ourselves, you may go, so okay, maybe I can't conclude within 10 tosses, so you will go to till 20 tosses or 30 tosses. After 30 tosses, you feel you got like 22 times heads. So what will you think? Like how will our mind tend to guess?
Bias point.
Yeah. So I'm seeing more heads than tails, so it is biased coin, and we guess it like biased. So if it is like some out of 30 or 50 tosses, it's like somewhere around 50 tosses. If you toss the coin 50 times, and you got somewhere 28 times heads and 22 times tails, so you will somewhat feel like it is not, it is an unbiased coin. Correct? So equally, I'm getting some more or less equal number of times I get head and more equal number of times tail. So how will we guess this? So what is the better estimate? And so we will look into all these things now. So how should we go? When to reject? Yeah. So now let's come to this setting. Okay. So this is what hypothesis testing will do. So what we do is we make up some setup and we will fix some restrictions, and depending upon the outputs we see, we fix whether to accept H0, accept this particular unbiased coin, accept matlab, so whether the coin is unbiased we will fix, or depending upon the test itself we will fix it is whether it is biased. So depending upon the test we will conclude. So we have to fix the test first, and then on that particular test, on that particular testings, depending upon the conclusions we get from the testings, we will conclude whether it is biased or unbiased coin. So this is how the setup of this hypothesis testing will be. So what we do is we take samples. So here in the example, samples means we toss the coin and we will note down the first what is the first outcome, second outcome, third outcome. Each of the outcome is a sample, and looking at the samples we decide between null hypothesis. So there is a term called null hypothesis, so which we are going to test. So actually null hypothesis.
So I have a question over here. So the hypothesis testing, when you are doing, we are doing it on the samples, but when you are taking the hypothesis, the assumption, that was done on the population or on the samples.
That was
like for any
that is
I
for
think
population.
sample.
No, population.
Population, right?
Yeah.
Okay.
That is for population.
So we are making the assumption for the population, and we are doing the testing on the samples collected from that population.
See, we collect samples from the population, and depending upon the samples, we test whether it is whether to accept null or whether to reject null. So that is why there will be errors in our prediction.
Yes, the conclusions that we make based on that, it is we are making that conclusions on the population, right?
No.
Testing on a sample and predicting on population.
See, what we do is you can't see, you take the coin itself. So one coin is biased and other coin is unbiased, and more or less this coin tossing, unbiased coin tossing, you know that if you toss it some 1000 or 2000 times, or Probability of getting head is 0.5 if it is unbiased, right?
Yes, sir.
So I have x which takes values between 0 and 1. 0 means tail, 1 means head. Okay. So what is the probability that x taking value 0 is 0.5? So this is population. X is the population.
Yes.
Correct. And what we do is we toss the coin 1 time, 2 times, 3 times. Those are the samples.
Yeah, say we're tossing it 50 times, so 50 samples
Okay,
are there.
50 samples you see. Okay. So depending
Yes.
upon these 50 samples, we conclude about this x.
Yes. Okay.
Okay.
Oh, yeah.
So that is how it will be. Okay. Now, what is null and what is alternate? Which one to be taken as null and which one to be taken as alternative hypothesis? So there are two hypotheses now. That means there are two different assumptions now. So one assumption versus another assumption. Okay. So which one to be taken as null hypothesis? So the item to be taken, the assumption to be taken for null is which one we are trying to verify. So I am trying to verify whether the given coin is unbiased or not. So I am trying to verify whether the coin is given unbiased or not. So my null hypothesis would be something like, so my null hypothesis is unbiased coin. So what I predict is, yes, this particular coin which you gave me is an unbiased coin. So this is what my assumption. I will make this assumption and I will start testing. So what is our assumption now? Whatever the coin I have given to you is an unbiased coin. This will be your assumption, basic assumption. Okay. And this particular assumption or whatever the thing we are trying to verify, we are trying to verify whether the given coin is unbiased or not. So this particular thing will fall into the null hypothesis case. So which one you are trying to verify? So here in this particular examples, so if I replace my battery of my vehicle, then it gives better mileage. So what is your null hypothesis here?
Same thing that if I replace battery of my vehicle, it will give better mileage.
Better mileage.
Better mileage.
So what should be your null hypothesis? What is your assumption now?
That it will give better mileage.
Yeah, giving better mileage is your assumption.
Null hypothesis and not giving better mileage is alternative.
Your alternate hypothesis. Yeah. So that is how it should be. So here also will gain weight. Gaining weight should be your null hypothesis. So this is what we are going to test. Either you gain weight or you will not gain weight. So whatever we are trying to verify, we are trying to verify whether I can gain weight or not. Correct?
If we choose an alternative hypothesis as null hypothesis by mistake, then how does the problem will progress?
So you will get opposite your whatever the assumptions whatever the conclusions you want to get from it, you will get the opposite of it.
Okay. So
and also
at
in
the end,
this
we will get
particular
the
course, no, see, the thing is, if you take your null hypothesis as you will lose weight. Okay. But we are not trying to verify that. What are we trying to verify? Whether you are gaining weight or not.
Yes.
It's not the opposite statement, whether you are losing weight or not.
Okay. We can go with that, sir.
Doing the opposite and
we can go with that if the statement is modified, like if I eat less, then I will lose weight. Yes.
I think it's a norm or something like that.
No, what I am trying to reach out is null hypothesis has to be framed based on the question, is it?
Yeah, based on the question.
That's how we should
based on the assumption or whatever the hypothesis is given to us, like whatever the person says you, or whatever the assumption we are taking is what null hypothesis.
Okay.
Okay.
Thank you.
So we will
So not able to hear, sir, right?
Yeah.
Yes, not audible.
Hello.
Yes, sir.
Yes,
Yes,
sir.
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 No audible, sir.
Okay. When did I leave? I don't know. Man.
Every time someone kicks you,
Hmm?
every time someone kicks you,
Uh-huh.
You
Okay.
lost at the time when you are explaining to build the hypothesis based on the question.
How come Saurav Kumar became host suddenly? Saurav, are you there?
I know
Sir,
him,
yes,
sir.
sir, I am there.
Can you make it
Host.
the main host left, I guess. So today Saurav Kumar got a chance to make me co-host. Hey, don't share anything, okay? You have the or you just give me the host access, man.
Okay, sir, I am trying.
Okay. Maybe. Okay, what am I explaining? Just a second. Just meanwhile, give me the co-host or host access, okay? हेलो सौरव कुमार
यस सर
क्या हो रहे
सर ये पता नहीं मुझे कैसे होस्ट बनना मैं
अधिक उस पर क्लिक कीजिए ना पार्टिसिपेंट्स पे
पार्टिसिपेंट्स का
Go to
और पार्टिसिपेंट्स पे
sir
क्लिक
name.
करके और सर के नेम पे क्लिक करके मोड पर कीजिए और उस पे आएगा सर का नेम उस पर मेक एज पोस्ट कर दीजिए
पोस्ट कर देंगे
कैसे होगा है
ओके
यस सर हाँ हो गया
एंड आई थिंक 2 घंटे के बाद अगर चला तो someone have to do it again okay I don't think I will but anyway okay where am I like where did the connection break
to select null and alternate how to select null and alternate
so our null should always be like which one we are trying to verify so that should be our null and then opposite is will be the alternative opposite is like just complement of the statement of our trying to verify so maybe if you see the examples you will get to know
sir just a small doubt here I think in case of weight like so I think the null hypothesis is always the existing condition like I will assume that eating more does not allow gaining weight and then the alternate will be that eating more leads to weight gain
no that is not see whatever the assumption we are trying to verify so we are trying to verify
so that should be an alternate hypothesis null is the current scenario existing condition
what is the existing condition now
existing condition means okay it does not increase it does not impact any it does not have it is not having any impact on weight gain and then alternate is that okay eating more leads to weight gain I'm just asking
I don't think see actually null hypothesis whatever we take in the null hypothesis is actually we are trying to verify Okay.
That's what we are trying to verify with respect to something, right?
With respect to something, which one we are trying to verify here?
So,
What
yeah.
null we are trying to verify?
So the current scenario will be null. I think when we solve problem, this thing will be more clear. Yes. Okay, sir.
Okay. So we will get a clarity there. So in the AQ 11.1 also, so there are some questions which we ask you to predict which one is the null and which one is. So when we see the simple and composite hypothesis, then we will see. Then we can understand it better.
Okay. Yes, no problem.
Okay. So here in this particular example, Sarvesh.
Yes, sir. So the content of week 11 and 12 both comes under inferential statistics, right?
Correct.
Okay. Thank you, sir.
H0 is okay. Our null hypothesis is we are trying to verify whether the given coin is unbiased or not. So therefore, our null hypothesis should be the coin is unbiased coin, and the alternate hypothesis should be biased coin. So that means unbiased coin means we will take it like probability of heads is 0.5 and alternate is probability of heads is 0.6. So this is our null hypothesis and this is our alternate hypothesis. Okay. Hello, am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay, let us see some examples then. So I'm just thinking whether this is how it is or not. Whatever we are trying to verify is what.
Yes, sir. It is
Am
right.
I correct?
Yes, sir.
You're audible, yes, sir. You're audible.
No. Am I correct or?
Yes, sir. You're correct.
Yes, of course.
Correct, right? So whatever null will be like whatever we are trying to test, and alternate will be the opposite of it or the complement of it.
Yes.
Okay. So in this particular example, this is how it will be.
Equal chances null set.
Sir, you can go to activity 10.1. There are two examples.
Yeah, I can. Okay, let me go to that activity 10.1.
In the first lecture, there's an example.
11.1, right?
Same.
Right, 11.1. Yeah.
11.1.
Okay, let me just share that screen.
On the lecture itself, there's a doubt, sir, like the derivation of the value.
Derivation of?
The value, sir, of the probability. So,
okay, we will see. In the first lecture itself, no?
Yes, sir.
Okay, we will see. Okay, here you can see the. Can you be able to see my screen?
Yes, sir.
Yes, right?
Yes, sir.
So here the question one, read out the question one. Just wait. A manufacturer of a certain brand of rice cereal claims that the average saturated fat content does not exceed 2.4. Okay, this is his claim, or this is the assumption that the rice cereal average saturated fat content does not exceed 2.4. So if this is the claim of his, or if this is the hypothesis, so how can we represent does not exceed 2.4?
Less than equal to 2.4. Less than equal to 2.4.
Less than or equal to 2.4, but we actually keep our hypothesis to be simple. Okay.
Yes.
So simple means it's actually equal.
Yes. Okay.
Okay. So our null should be like mu is equals to 2.4. So his claim is, what is his claim? So his claim is it is less than 2.4. Then what should be the alternative? Complement of
greater than 2.4.
More than 2.4.
More than 2.4. So our
second option is
second option.
Second option. So this should be the correct answer.
But that is wrong.
That is wrong.
The third option is correct, sir.
Yes, as per answer sheet, that is wrong, and we all are surprised.
That's why even I didn't understand it. Actually.
Correct. I was about to post in discourse.
Okay.
And so one more query, if we want to genuinely check whether it is less than 2.4, still we will take null hypothesis is equal to 2.4.
See, because in this particular course we are only dealing with simple type.
Okay,
simple
okay.
Null.
Otherwise it would have been less than equal to 2.4.
So what hypothesis is being tested if a judge commits this is related to type 1.
So the second one is all right, but the first one is like little bit.
Yes, second one is all right. That we are getting the right answer.
Second one is just claims that 55% of all private residents.
Correct. Equal to and not equal to.
Like in the first, the problem is that if the third option is correct, then whether null is correct or alternative is correct, the statement becomes correct in both the scenarios, because it is either equal to or less than.
I think this answer is wrong.
No, not wrong. I am confusing. I am making you get confused.
No, sir, but how come so many people will say wrong answers? Sir, if you are saying that it should be greater than.
So I have a point. So what I'm saying is that when he said the manufacturer of a certain brand of rice claims that the average saturated fat content does not exceed 2.4. So if H naught is correct, then it is equals to 2.4. If it is alternative is correct, then less than 2.4. So in either case, the statement is correct. So I cannot refute the statement in any case, whether alternative is correct or the null is correct.
Does not exist means more than 2.4, no, sir?
Yes.
So
alternate should be more
maybe
than 2.4.
There is some wording wrong in this.
Yes, alternate should be more than 2.4.
So actually, it's quite clear on this, sir, because when you're saying that it does not exceed, it can equal maximum, at most it can be 2.4. So the H naught itself is.
It's at least.
H naught itself is stated wrong, I guess.
Statement is correct, sir, because if you read the statement, saturated fat content is always the one which is not required for the body.
Yes, correct.
So that's, if you try to read the statement, absolutely statement is correct. Answers could be wrong because we do not want higher saturated fat content in the products what any manufacturer is selling.
Correct.
Exactly, sir. Why will we check whether it is less? I mean, it's not necessary not to check it is less than 2.4.
But why to check for the less than? We can think that 2.4 is a boundary, and it does not exceed that boundary.
So we are looking at from, let's say, there are people who are not so inclined towards the health aspects of this. I'm talking from the perspective of just a typical calculation, like hypothesis, how to answer this question.
Okay.
So you will not be conversant with the domain at all. So what I was looking at is, okay, this statement says that average saturated fat content does not exceed, which means that if it doesn't exceed, it's good for health or something like that. So it cannot be 22.4 maximum, lesser than or equal to 2.4 could be the H naught. But I don't find that at all in the options.
So in that case, alternate will be greater than 2.4.
Wait. Okay, correct. Not this thing. So I got now. See, whatever I said, there is something wrong. So what exactly this null hypothesis is actually null. So if you look at the word null, so what we actually tend to do is we actually try to reject this particular null. So whatever null we are trying to take should be in our rejection region, and we have to try to prove alternative is correct. Okay. Did you get? So even in the lecture also, so Professor Andrew is trying to get that particular, trying to test the particular coin is counterfeit or not. Okay, not he is testing for counterfeit or not for.
But in that case, he has also taken H naught as a authentic coin and HA, yes, and HA as a counterfeit
coin, and he's trying to verify. He's trying to make his alternative correct, and he's trying to verify the opposite one, and he will try to reject it. So every time what we do is we take null and we try to reject that null. so that our claim or our assumption is correct, becomes correct.
Yes, yes.
Okay. So whatever I said is wrong, so that should be opposite of it. So you see, here, whatever here. So this is my claim. Okay, this is my claim. In order to make this true, what I do is I take the opposite of it and I will try to reject it.
So basically, the aim is to reject the null hypothesis and prove that alternate is true. Is it?
Yeah, yeah.
So, no,
Okay.
sir, I don't think so, because null hypothesis, it depends on how the whole domain you are handling the whole questions. Null
So then,
hypothesis is like
11
you
point-
stated, accepted fact is stated. If you are able to prove it, then it's accepted. If it's not able to prove, then your assumption is wrong. But this the blanket statement that X naught is always false is totally confusing. Actually, I don't think it holds water.
So in that case, question number 2 should be like different one.
Yes, sir.
Okay, I
Then
will
question
look at
number
this
2.
question number 1.
Yeah, because with the same logic, if we answered the second and third, we are getting it right. But first, we are getting it wrong. So we are not understanding actually how to go about it.
Correct. Second and third, we are getting the right answer. So there must be something wrong in.
Probably we can post in Discord and check.
Okay, just post it in the Discord. Does not exceed is the claim. Does not exceed.
Does not exist means alternate will be greater than 2.4.
Greater than 2.4 should be the alternative. Okay, we will check it again, and if I am wrong, I will just post it in the Discord. Okay. So as of now, even I will be agreeing to you guys. Maybe while in this lecture itself, we will get an idea when we deal with examples.
Maybe it's like that the null hypothesis or alternate hypothesis, one of them have to be correct.
One of
If
them.
If null hypothesis is proven wrong, then alternative hypothesis should be correct. So that explains the option number 3.
So my question is, for that, in that particular question, so what it tells you when you reject null? So is your claim correct?
Yes,
can I add to that question which you just asked? Right now it is null is saying does not exceed 2.4. Then the hypothesis null the alternate will be less than 2.4, isn't it?
Yes. And null is equal to 2.4. When we reject null, then the alternative will be automatically proven that it is less than 2.4.
Okay. What if we accept null?
Accept means it's win-win case.
Yeah, if you accept null, you are saying it does not exceed. That's all.
Yes.
See, what is the need of performing the test?
It depends on the question that you're asking. If I say it exceeds, then that is null hypothesis. If I say it does not exceed, that is null hypothesis. Alternate will be the opposite of the null hypothesis. That's
opposite of the null hypothesis.
That's all. So if I say it does not exceed, then that is a null hypothesis. Then my alternate will be less than.
Will it be opposite or different from null hypothesis?
It has to be opposite, my dear. It is not about different.
Yeah, it's the counter of null hypothesis.
Here, it's not stated that way.
But generally, we in the next some of the lectures that are after that. In some of that, they have considered, sir has considered like say the null attitude towards that. Like if one is different than the other, then the no difference is being taken as a null. And the other is there is a difference is taken as alternate hypothesis. So there is some kind of a null attitude towards the null hypothesis, like neutral type of attitude.
Yeah. See, that means simple kind of null we deal, right? Okay.
Yes, like if there is some kind of process, and it is said that there is this say a process is better than another process, so then null is like there is no difference between the process. So it's a neutral type of attitude that is being taken.
Correct. So what is that statement? What is the claim?
Again, one of the examples I saw, like if say process 1 is better than process 2,
okay,
then null is taken as process 1. There is no difference between process 1 and process 2, and the alternative is it is greater than process 2 or less than.
The same statement they took, or the opposite of the statement? If we claim that process 1 is better than process 2, that means process 1 is greater than process 2. Is that our claim? So what is the alternate hypothesis they took? Is it like process 1 greater than process 2 or process 1 less than process
2? I think it is greater than or less, like it is greater than, like if it is greater, then it is greater.
Then it is greater. So
Yeah,
whatever
I
their
think
claim, their claim, they have taken it for alternative. But that should not be the case. Okay, anyway, we move while we solve the problems I just said, right? We will try to figure out which one is null and which one is alternate. Okay. Okay. So let us deal with an example that is better. So in the lecture, sir has tossed it 3 times, but I want to toss it 4 times. No, just forget that thing as of now. We will figure it out. So one will be null and a complement of null will be the alternate. Okay. And just come to this particular point now. So suppose we toss the coin 4 times. So what are the possible outcomes I can have? So how many possible outcomes I can have?
16.
2 to the power
16.
4.
16.
16 outcomes. 2 to the power 4.
Oh yeah, correct. So what are they?
All 1 1. You can write, sir.
Okay. So it starts from all. You can have all heads.
H tail.
Right.
Like this, right? And so on. And the last one is tail. So all heads, 3 heads, 2 heads, 1 head, and then no heads. Okay, these are the possible outcomes. So what we do is, these are the possible outcomes of a coin. So these many 16 possible outcomes are there. So out of these 16 possible outcomes, only one outcome will be ours. So if you toss the coin 4 times, among these 16, only one will be our sample, right? Correct? Or if you toss the coin, you will have one among these 16, not all the 16. So either first time you toss, if it is tail, and the next 3 times it is 3 heads. So then this particular outcome is the possible outcome. Is the outcome you got. So whatever the outcome we get will be one of the among these 16 possible outcomes. Okay. So keep that in mind now. Now what we do is, for some outcomes we will accept H0, and for other outcomes we will reject H0. So what are the common outcomes for which we will accept H0? So let's say our H0 is probability of head is 0.5, and our HA is probability of head is something 0.6. And we don't worry about this thing, we only worry about this thing. So whether to accept this or whether to reject this and take the other one. Okay. So usually if I toss the coin 4 times, for what outcomes I can accept H0? So usually for which are the following outcomes we will accept H0?
2 heads.
Yeah, with 2 heads. Only maybe somewhere head tail, or maybe head tail, or head tail head. So if your outcomes are like this, so then you probably tend to accept H0, saying that it is an unbiased coin. correct? Or if you have only one head and three tails, so you know that either these two are correct, and you have only observed one head and other three are tails. So that means the probability of getting heads is very less than 0.5. So within this 4 times toss. So even in this case also you feel like, okay, even this also may come under this particular unbiased coin, because the other coin you have is it has high chance of getting heads. So if you don't get more than 2 heads, you possibly think that you will accept your heads, not saying that this particular coin is an unbiased coin. So treat it like null. In null, I have unbiased coin. Hmm?
But for unbiased coin, two heads and two tails is the most reasonably like H naught should be stated like this, right? Because if we are saying that the coin is unbiased, your whatever be the number of trials, you would expect that the sample should come out as two heads and two tails. Anything else we can put it in H tail. That's my thinking.
So anything. See, even these also will not. This is not a better testing. Okay. So tossing only 4 times and deciding whether it is biased or unbiased is actually an illogical thing. But suppose we toss only 4 times and we have only that much time to toss the coins. Okay. So you toss only 4 times. Within 1 minute you have to conclude. So you can only toss 4 times and note down, and you have to compute something, right? So you thought of tossing it only 4 times. And what logically what logical conclusions you can draw? So if you have seen some 3 tails and 1 head, so you will feel like, okay, this particular coin is actually giving me more tails than heads. So that means either I should get more heads. If it is biased coin, I should get more heads. If I am not getting more heads, then I feel like this is an unbiased coin. But if I get something like 3 heads and 1 tail, so what logical conclusion will you draw from this?
It's a biased coin.
It's a biased coin, right? So you are seeing some 3 heads within the 4 tosses. So suppose I'm just saying, so it's not 4 tosses, you can draw some conclusion. If you have to draw conclusions, this is what we draw. So if you see some 4 heads out of 4 tosses, so even in this case also we feel like this is somewhat a biased coin, and we say we reject H0 and we take alternative to be true.
So, but that is so. But looking at, let's say we are taking the sample three tails and 1 head. Okay. 3 tails. So looking at that, we would feel that okay, it looks like the probability for tail is more, which means that HA can be rejected, because HA here states that head would
probability of heads is
yes 0.6. That's that. Right. So which means that we'll have to bank on H0 only, right?
Yeah. We should only look at H0 only, not HA. So don't worry about HA. We should only look about H0 only. And these are my possible logical assumptions. Okay. So these are, you may be different and someone may be taken different things. So someone will reject this also. Tail, head. So even they feel like, okay, this is not biased. Maybe he just said heads will be more, but maybe tails are more. You can think like that, and you can keep this particular outcome as also. If you see this particular outcome also, then you will reject H0. Okay, this is difference from 1 to 1 person. Okay, so for some outcomes we will accept H0, and for other outcomes we will reject H0. When to accept, which one is the logical thing, which one is the worst thing to do, and those things we will see now. But as of now, what we can understand is, out of these possible outcomes, out of these possible 16 outcomes, so few outcomes, if you see few outcomes, we will accept H0. That means we will say it is unbiased. And for other outcomes, we will say it is biased. We will reject H0. Rejecting H0 means we are accepting alternative. So both are same. So rejecting H0 is same as accept accept alternate. Okay. Okay.
So you want to say they are not conjugates, sir?
Hmm?
They are not. They will not fulfill the other one automatically.
Which one will not fill?
If we are not rejecting H0.
H0.
It's not equivalent to we are accepting HA, right, sir?
It's equivalent
It is.
to it is. So I'm just by implying, okay. So you are rejecting H0 or accepting HA, both are same. If you reject H0, that means you are accepting HA. Okay, it's between H0 versus HA.
It's like, sir, if you are rejecting non-veg, then you have to
Yeah,
accept veg.
you have to accept, you have to eat veg. Correct.
All right. Thank you, sir.
Okay. Yeah. So one thing to take away from this is whatever the possible outcomes are there, among those all the possible outcomes, for few outcomes, we will accept H0 like these cases. So if your outcomes are like this, we will say the coin is unbiased and we will accept H0. That is what accepting H0 means. And few other outcomes, we will actually reject H0. So which is accepting alternative, which is biased coin. You conclude that this is a biased coin. Okay. And there is another A, there is new set A. We define a new set A, which is the set of all outcomes for which we will accept H0. Okay. So we have some outcomes where we will accept H0. We will have some outcomes where we will reject H0. But when I put all these accepting outcomes into one set,
Hello.
Sir, unable to hear you.
Hello, sir. You are not audible.
I think it's been 1 hour, right? So connection might got lost.
Oh, no, he is in the meeting.
No, but it's for 2 hours, right? This meeting is.
Now he is gone. Oh.
Saurabh?
It's for 2 hours. It's for 2 hours, right? It's 8 to 10, right?
Accept sir and make him a host.
सर ज्वाइन करेंगे तब तो भाई सर दिख ही नहीं रहे कैसे इनको होस्ट होना
सर को ज्वाइन कर देते
आएंगे सर
को ज्वाइन कर देते हैं
आप सर को को होस्ट बना देना क्योंकि ठीक क्योंकि फिर आपका 1 घंटा 1 आवर खत्म होगा ठीक
Hello.
Yes, sir.
Yes, sir.
Sir, Saurabh kicked you.
No, sir, no, sir. I have not.
No, I know. Where did I stop again? I'm wasting some 2 minutes, man. I'm getting logged out, but I'm still explaining, and बाद में पता चल रहा है कि okay, you made me co-host this time.
We're talking about set A, sir. Set A, how to.
Okay. So when I didn't get the
last you said was, so if we put all the accepting outcomes in one set and then we could hear it.
Then
that's what set A is. You just started sentence, sir.
Okay, I just started talking about such. Then you haven't seen these things then. Okay, I'm asking a question and no one replied, then I got logged out.
Yes, sir.
Okay, so the thing is, for few things we will accept H0, for few outcomes we will accept H0, for other outcomes we will reject H0. And if I keep all the accepting outcomes, accepting H0 outcomes into one set, that particular set is called A. And here in this example, I have tossed the coin 4 times, right? So when I say my set A, if I define like this, if I define my set A as, so A, so all the outcomes, so I will accept H0, this is what my statement is. I will accept H0 if I see 2 or less than 2 heads. So if I say, if I see 2 or less than 2 heads in my outcomes, then I will accept H0. Then what all outcomes will be in my set A?
H T T T H T H T T T T H T T. Yes, sir.
So T H T
H H T T H T H T
T T T T T H and something like H H T T.
Less than or equals to, I think you should write here.
So 2 or less than 2 or less than or equal to 2. So if I see less than or equal to 2 heads, so what am I saying is I will accept H0 if I see less than or equal to 2 heads. Okay, if I am accepting H0, what all the outcomes that will be in my set A is my question. So either I should have 2 heads or less than 2 heads. So I will see all the outcomes which has 2 heads and less than 2 heads also. Correct? So those all will come into my set A. So here it will be like H, and there will be some 6, right? Tail, head, head, tail. Four factorial by 2 factorial into 2 factorial. Correct? Any repeating things?
There will be a lot, sir.
Why there will be a lot? So number of arrangements is 4 factorial by 2 factorial into 2 factorial, right?
So 4 T's will not be there, sir. 4 T's. 4 T's.
4 T's will not be there. Yeah, 4 T's will also be there. Okay. No, I am asking for this thing. 2 heads and 2 tails, only 6 possibilities, right?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
This is 3 into 2, right? 6. So we'll have six different. No, Kaipe I didn't have the duplicate, right? So these are the 6 possible outcomes, right? Head, head, tail, tail, head, tail, head, tail, head, tail, tail, head, tail, head, head, tail, tail, head, tail, head, tail, tail, head, head. Yes, I think these are the 6 possibilities. So we will get 6 possibilities. I am not repeating anything. And also 4 tails also, what we see is less than 2 heads only, right? So 0 heads. So this is 0 heads, this is 1 head, and these are 2 heads. So out of the 16 possible outcomes, so 1, 2, 3, 4, 4 plus 6, 10, 11. So if I see 11, any of these 11 outcomes, I will accept H0. And if I see other than these 11 outcomes, there are 5 more outcomes. So if I see among those 5 outcomes, what I will do, I will reject H0. Okay. Understood?
Can you repeat, sir?
So what I said is, when I toss a coin 4 times, I will accept, so I will conclude that this particular coin is an unbiased coin if I see less than or equal to 2 heads. Okay, this is what I said.
Yes. Okay.
Okay. So when I toss the coin, So how many different possible ways I can say that this particular thing is an unbiased coin? So if I see some 2 heads and 2 tails, or less than 2 heads, correct? So that is what I said, right? That is what my statement is.
Yes, sir.
Okay. So when I said I will conclude this particular coin is an unbiased coin. Out of my 4 tosses, if I see less than or equal to two heads, then I will say this is an unbiased coin. So less than or equal to 2 heads means either 0 heads or 1 head or 2 heads. Correct? Correct? Less than
Yes, sir.
equal to 2 heads. Okay?
Yes, sir.
So what are the possible outcomes of this particular event, less than or equal to 2 heads?
10, sir.
11 by 16.
Yeah, these are the possible outcomes. Correct? For less than or equal to 2 heads, these are the 11 possible outcomes. So if you see any of these outcomes, what will you conclude?
We will accept H0.
Accepting H0 means
Unbiased coin, unbiased coin.
so we will say that it is an unbiased coin because the probability of getting head is less than or equal to 0.5. It's not even greater than 0.5. Okay. So this is some logical acceptance of taking set A. But this is not, this may not be a good set also. So either you can take like this, or you can simply say you won't even take anything. So you simply say I don't even accept anything. So whatever the outcome I see, I simply reject H0, saying that it is not unbiased coin, it is a biased coin. So that means, so whatever the outcome I see, so there is no acceptance set. So that means you are not interested to accept anything. So you are not interested to accept H0. Okay. So you are willing to reject H0, whatever the outcome you see. Whatever the outcome means, you toss the coin 4 times. Irrespective of what you get, you simply say, I'm going to reject. So it's not an unbiased coin. It is always a biased coin. I strongly believe that it is a biased coin. I don't need to check at all. So that is what, so there is no acceptance outcome. So for no outcome or for any outcome, I will not accept. I will reject. For every outcome, I will reject H0. That means there are no outcomes that we will accept H0. Okay, then even that is also one possible set A. So you have to choose A logically, so that you will predict it better. So your prediction is better. Okay. Okay. Understand?
Yes, sir.
Understand
Sir,
about A?
no, I didn't understand a couple of things, sir. Can I speak?
Yeah.
Sir, first of all, we have taken experiment where a sample coin is being tossed 4 times.
Okay.
And like what you have done, I'm just summarizing if I got this correct. Then we wanted to find out if it's biased or not.
Yeah.
And then what we have done is we have like created a null hypothesis that there are two H0 and HA. And we have said that we will be accepting it as a unbiased coin only if we see that there are 2 heads or less than 2 heads. Am I correct so far? So like in the given set A, there are 11 possibilities.
Yeah.
Right. So now, sir, where I kind of like didn't got lost or didn't understand is that like what, like I have got 11 possibilities in HA. Now what do I do? Like, do I reject it or do I accept it?
Okay.
What is it that we're going to do?
So we are going to toss the coin only 4 times, correct?
Yes, yes.
And there is one set of outcome among these 16 outcomes.
Yes, every sample would have either of these 16 outcomes.
So if you are taking only one sample, that means only one of these outcomes you will see exactly. When you perform the experiment, you will see only one outcome.
Correct. And we have selected only 11 of these outcomes to accept. Whether the coin is...
of these outcomes to accept, matlab, to say that this particular coin is unbiased. So
Yes.
when I toss the coin 4 times, if I see any of this outcome as your outcome, like any of this particular 11 things matches your outcome matlab when you toss the coin 4 times, maybe you got something like head head tail tail, so it's inside this 11 outcomes.
Yes.
Yes.
So if it is inside this 11 outcomes, we will accept our null.
One for once also.
From one observation only.
From one observation only. Suppose we are only tossing it 4 times. That's it.
Okay.
Only
Okay.
one time we are tossing. We are
Like only one set of 4 observations. Like
yeah, only one set of 4 observations only we are doing. Okay, you are allowed to do only what you are allowed to do. You are allowed to do only coin toss only for 4 times, man. Okay.
So suppose that we tossed a coin for 4 times, right? And for one time I got my result which is inside A. But for 3 times that is not inside A. Then how we can say that it's unbiased coin?
See, that is a different case. Okay, there your samples are different. Matlab, you are taking more than one sample. Okay, but here what we are doing is we are only doing the test once.
Okay.
Okay. By doing
if we toss once and the result is in A, then we can say that it's unbiased.
Yeah, so that is why we have some errors in your testing. Okay, so you may get this head head tail tail, and you might conclude that this is an unbiased coin, but maybe that coin is actually an biased coin.
So
Sometimes
we should take the large samples.
So see, that is what I said. Only tossing 4 times is an illogical thing. Concluding with it, by tossing it 4 times, you cannot conclude it correctly.
Yes.
Correct.
Yes.
But in order to understand, we took only 4, and even professor took only 3. So there you have only 8 outcomes. So out of those 8 outcomes, few outcomes you will accept H0. If you see few outcomes, you will accept H0, and other few outcomes you will reject H0. Okay. So you do only one time. One time means only 4 times you toss the coin and see the output of that coin. That particular output, that set of output will, if it is in either of these 11 things, what you do, you accept H0. If it is the other 5, you will reject H0. Okay. Okay.
Yes, sir.
Anirban,
got it, sir. Thank you.
Yeah. So the test is only happening once. So that is why you see there is also one more statement called every set A corresponds to a test. So if this is my A, then I will have one test. And the test is, if I see, this is the testing. If I see less than or equal to 2 heads, I will accept H0. So this is what I am going to test. Whether I am going to get 2 heads or less than 2 heads or more than 2 heads. Looking at the test, I will conclude whether it is unbiased or biased. Okay. And if I change A, or if I took only these 4, I just said only if I see, so there is one more set. So one more test. So other test is like, if I see only 2 heads, then only I will accept H0. So this is one more test. So this is another test where I am testing, either I am testing for 2 heads or less than or greater than 2 heads. So this is my testing. So if I see 2 heads out of these 4 times I toss, then I will accept H0, or else I will reject H0. So this is the test I am going to do. For this test, I will have one more different A. So what is that particular A? Set A. So for this test,
HHTT.
Yeah, I will have some HHTT,
HTT.
Yeah, those 6 outcomes. So HHTT, THTH, TTHH, TH, TH, HT.
First and
So now
third got repeated. First and third got repeated.
First and third got repeated, yeah. HTTH.
TTHH.
Yeah, HTTH. Okay. Now you see, previously our A is something, it has some 11 outcomes. But now the new A has only 6 outcomes. So depending upon the test, my A will depend. And depending upon the A I choose, my test varies. Okay, understand? Understood this thing? For each A, for every set A, there is a test, corresponding test. And for every corresponding test, there will be some A. Acceptance set. This is called nothing but acceptance set. Whatever the set we form is called acceptance set, where if my outcome falls into that acceptance set, then I will accept H0. If it does not fall in that acceptance set, we will reject H0. Okay, and falling and not falling is based on this particular test. So we toss the coin, and if you see 2 heads among those 4 times you toss, then I will accept my null. Or else if I didn't see, if I see only 1 head, or if I have seen 3 heads, then I will reject H0. So rejecting H0 means it is unbiased. I don't say, I will say it is biased. That means accepting HA. Okay. Now got the understanding, like what exactly is this A, what is this A, and what exactly is it test, and how each A has different tests, and different tests has different A's. Okay, acceptance sets.
That we have to design, right, sir?
Yeah, that we have to design. And there are some good tests and there are some bad tests. So depending upon the good acceptance set we have, that will give us some good tests. And what are bad tests? So in this particular example only, give me one bad test. Any bad tests like?
In the first one, we have taken 4 T's, no, sir. That is a bad test because all the 4 tiles we got it in the first example.
Okay.
Yes, sir, there are 2 heads you told. In that example, taking 4 T's is absolutely appear to be biased rather than unbiased. One example.
Okay. Simply to understand, see this particular thing. So if my test is saying that, so whatever your outcome is, I say it is biased. Is this a good test? Like whatever the outcome you get, I say that is a bad test.
No, it's a bad test.
It's a bad test. And there is another bad test. Whatever the test you give, whatever the outcome is, I say it is unbiased. Okay, I will accept everything. So I will accept everything. Whatever the outcome comes, I will accept it. And it is something like all the 16 possible outcomes will be in my set A. So this is my set A now. And whatever the outcome is, outcome will always be in this acceptance set. And we will accept H0, saying that it is an unbiased coin. So this is also a bad test, right?
Yes.
Right. Whatever the outcome is, I say it is unbiased. So these are some bad tests, and there are some good tests. So whatever I said, these 2 may look like some good tests. So if I see less than or equal to 2 heads, so was logically somewhat correct. Better than these tests what we did now. Correct. So better than these 2 sets. Can I say that?
Yes, sir. These are bad sets.
Yeah.
Bad test.
These are bad tests, and this is somewhat better than this test, right?
Yes.
So we will see those things also. I have below examples, so there we can discuss more. See, this is how the setup of an acceptance set is. So if you have some n samples which are coming from IIDX, and there is some null hypothesis and there is some alternative hypothesis, and my x is belonging to subscript x. So what is this subscript x means?
Alphabet, no, all possible values of x.
So what is that?
X1, X2, X3, and 2xn.
So have you seen this?
This is X is kind of superset. X is acceptable subset.
Have you seen this term anywhere?
Sample space. Yes, sir.
Yes.
What is this?
Sample space.
All possible outcomes. All possible
Outcomes.
exhaustive, yes.
Correct.
Yes.
So, in our example, what this represents? What
16.
is this?
16.
Yeah, 16. So no, it's not number of all possible outcomes. It's actually, so this possible outcomes I have written, right? This 16.
11.
So this is
correct.
So this is the sample space.
Sir, in the lecture, there's also the like the number of sets 2 power 8, 256.
We will look into that also. See,
sir, sample space is 16, not 11, sir, right?
16. See,
yes, correct.
So
correct. Got it.
Has 16 possible outcomes, and the set
no,
of
someone said 11 in between.
No, they have corrected. So the set of all possible outcomes is what the sample space means. So this particular X comes from this sample space, right? This particular X is nothing but tossing the coin 4 times, okay? Understood?
Yep.
Yes, sir.
Okay. Okay, let me make it easier. So let me say I am tossing a coin once is the experiment. Tossing a coin is the experiment. Now tell me what is the sample space? Experiment is toss a coin.
How many times you are tossing?
One time. Tossing a coin is the experiment.
Head and tail samples.
Okay, tossing a coin is the experiment. So what is the sample space?
HT.
H or T. Correct? So treat it like this. Then this will be easier for you. So if this is X, let's say X is actually tossing the coin, and this X1, X2 to Xn represents, this is the first toss, second toss, like this is the nth toss. Okay. Okay. So this is the setup. Okay. So we have tossed the coin n times, and tossing a coin is the experiment, and that is X. So that random variable X takes values. So this particular X is 0 if it is tail, and 1 if it is head. Okay. Now X1 represents the first toss. So whether it takes values 0 or 1 depending upon whether it is head or tail. Now if X is this sample space which has sample space head tail. So now you see, if I take this element X1, X2 to Xn. So I hope you all are doing max 2 and you know what is an element in nth space.
What is that, sir? What is that?
How many of you know?
What is that?
A point on nth dimensional space. No?
Yes, sir. Yes, sir.
No. Okay, leave it. So it just
So your question is not clear, sir, actually. What did you ask, sir?
So my question is, how many of you know the n point in nth dimension? So how do you represent a point in?
Yes, same way like this, sir. X1, X2, X3, and Xn.
If it
in terms of vector, X1, X2 up to Xn.
Correct. In terms of vector, you represent. So if it is 2-dimensional, it is like x comma y. Correct. So if it is 2-dimensional, it is x comma y. So if it is n-dimensional, it will be like something like x1 comma x2 comma and so on xn. It represents as a vector. So here also we take collectively the outcomes of x1, x2, x3, xn, and this will belong to subscript to the power n. So now, in order to understand it better, now if you toss a coin 4 times, so the same example I have taken, if you toss a coin 4 times, my outcomes will be of pairs of 4. So head, head. So wherein all the 4 times I toss, it's all the 4 are heads, and this is how the outcomes will be. So understand this. So if you have this subscript x has head and tail, then subscript power 4 will have outcome somewhat like this: head 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 tail head head something like tail head. So like this, all the 16 outcomes you have. Okay. Take some time to understand.
It's all the possible outcomes.
It's actually all the possible outcomes, but each of the element will have four letters.
Yes, sir.
Not one letter.
Yes, sir.
Okay. If it is power 1, you see only one letter, comma one letter, head, comma tail. So if you toss a coin 2 times, it will be like head head, head tail, tail head, tail tail. So now you see two letters inside one element. So you consider it as an one element. So you sets have elements, right? So this is a 2-dimensional element. Maybe you treat it like that, 2-dimensional element. If you toss a coin 4 times, it's a 4-dimensional element like this. So x1, x2, x3, x4. So there will be 4 letters, whether it is head or tail, and collectively is an element in xn. Okay. Okay, this head is one element in this subscript x to the power n. So simply saying, this is a sample space for one coin toss, and this is a sample space for n coin tosses, wherein each of the element will have n outcomes. Okay, head. All the n times I toss the coin, it can be heads. So that h. So one element is h. N times is one element. So in this x to the power n. Okay, subscript x to the power n. Okay. So I'm taking time, I'm spending time here because you understand this subscripts. See, in the lecture, everything is clearly explained, but these things sir has moved it very quickly. So you have to understand what this is and what are the elements. So this particular belongs to. So what this represent? This particular thing is an element in this particular set. Correct?
Belongs to. Yes, belongs to.
Belongs to. So this is an element. You have to understand. So the left side, what you are seeing is an element, and this particular thing is a set. Okay. So this is an element that comes from this set. If x belongs to this set, then this particular x1 comma x2 comma xn, this particular element will come from subscript x to the power n. So for understanding, you take one example, coin subscript x, and you see x square, x to the power 4, some x to the power 8. So if you see the outcomes you see for subscript x square, which is tossing a coin 2 times. So I will have 2 outcomes. So first time I will represent it as x1 and x2. Collectively I will look at the elements, outcomes, head or head tail or tail head or tail tail, like this. So these are the elements, and this is a set, and these are the elements. This will be an element in this subscript n. Okay. Okay.
So is it similar to that R2 space and R3 space which we learned in
R2, R3 like
okay,
that?
Okay. So it's not literally x raised to n, right? It is that space you are talking about. That n is that
space. See here,
okay.
X is actually a set of containing 2 elements.
Okay.
Okay, this is a set. So similarly, R is a set, right? Set of real numbers is what R is.
Right.
Right? Here R can take any value from minus infinity to plus infinity, but this particular X,
right,
take everything. X can
got
take
it.
head or tail. If X
Yeah.
is head or tail, then X subscript to the power n will be like head n times, or
Right.
all heads with one tail at the end, n minus one heads and one tail at the end. It's an n dimensional.
Okay, got it, sir. Thank you.
Okay. Yeah. So now once you have this, any subset A which is coming from this subscript to the power n, subscript x to the power n, is an acceptance set. Okay, any subset you take. So now this is a set and this will have a subsets, correct? So now here itself in the above example, so I will again and again I will take this example. So I have 16 possible outcomes and my sample space x is actually with 16 possible outcomes. So what are the number of subsets that are possible out of this 16?
2 to the power 16.
So if yeah, correct, that is correct. So if my set contains 16 elements, how many subsets I can form with those 16 elements?
2 power 16.
Yeah, 2 to the power 16. Yeah, 2
To the power
n.
16.
Correct, right? So I have some 3 elements.
Huge numbers.
Now my power set. So actually power set contains all the subsets, right?
Yes, yes.
Power set is actually the set of all subsets. Okay, if you don't want to bring those terms, we can simply talk about the number of subsets this contains. So the number of subsets are 5, 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3.
1 to 3 itself.
Actually 2 cube. So if my set contains 3 elements, the number of subsets of S will be 2 to the power 3. So similarly, if my set S contains some n elements, so number of subsets
2
will
power
be 2
n.
to the power n. So any subset among these 2 to the power n subsets, every subset is one acceptance set. Okay, any subset among those 2 to the power n subsets is an acceptance set. So if I have, so here we have something like 16 outcomes, right? So let's say this is 4 and I have head, like this, head, tail, like this, tail, tail. So these are 16 elements and the number of subsets I have is 2 to the power 16. Okay. So for this 2 to the power 16 subsets, so I have 2 to the power 16 acceptance sets. So if I have 2 to the power 16 acceptance sets, so I will have 2 to the power 16 tests corresponding to each acceptance set. There will be a test, correct?
Yes, sir. Yes, sir.
So if I have 2 to the power 16 acceptance sets, I will have 2 to the power 16 tests. So among these possible all 2 to the power 16 tests, which one is the best set, best test, or which one is the best acceptance test? So how do we choose that?
How to decide that?
How to decide that is depends on the size and power of a test. So each of the following each of these 2 to the power 16 tests will have size and also power. Depending upon this size and power, so we will decide which one is better. So size and power are numerical values. So if we have numerical values, then we can compare and decide which one is a better test than the other. So what are this size and So yeah, so what is our test in between? Test is something like, we know, right? If my outcome belongs to my acceptance set, then we accept H0, or else we will reject H0. So that is what I explained in the above also. So if I toss the coin 4 times, if I see that particular outcome in my acceptance set, then I accept H0, or else I will reject H0. Okay, so depending upon, yeah, just now we have seen 2 to the power 16 acceptable tests. That means there are acceptable sets. That means there are 2 to the power 16 sets, tests. So among these 2 to the power 16 tests, which one is a better test? So that is what we are going to find. So depending upon size, just now I said, depending upon size and power of a test, we will conclude which one is better. So what is size and power of a test? So size is actually also called as significance level, which is denoted as alpha. So it is actually the probability of type 1 error. Okay. So what is type 1 error now? So alpha I just defined. So the significance level, just now I have defined it as, it is the probability of occurrence of type 1 error. So that means alpha is actually probability of type 1 error. But what is type 1 error? So which one is called type 1 error? Anyone?
Sir, H0, you are rejecting H0, but whereas you should be accepting it actually.
Like rejecting null hypothesis when it is true.
Correct, correct. So type 1 error is where we reject H0, but
it is true.
Actually true. So that means, so whatever the example we are talking about the very first example. Okay. So whether it is biased coin or unbiased coin, we are testing it. And we said we have taken null as biased coin, which is probability of unbiased coin, which is probability of head is 0.5, and alternative as probability of head is something like 0.6. Okay, so you have tossed the coin 4 times, and yeah, your acceptance set is something like only 2 heads. Okay, so if I see only 2 heads, I will accept H0. This is my acceptance set, and the test is only 2 heads. So yeah, this is the test, and you write the acceptance set. So you will have some 6 outcomes. So only 2 heads is the test, and the acceptance set will be head, head, tail, tail, like this. There will be some 6 outcomes. Now what happens is, I have given you the counterfeit coin or the biased coin. Okay, so I have given you the biased coin, but when you toss the coin, you got actually head, head, tail, tail. So now what we do? So did you understand the setup?
Hello?
Did we understand the setup? Am I audible?
Yes, sir.
Yes, sir.
Okay, the test is only 2 heads. So I will accept H0 if I see only 2 heads when I toss the coin 4 times.
Right.
Okay, and I have given you this coin only. Which one? Unbiased coin only. I have given you the unbiased coin. See, H0 is true. So H0 is true means that is an unbiased coin. I have given you the unbiased coin, and you started tossing the coin, but to our bad luck, it it was actually something like head, tail, tail, tail. So you have observed this thing. What we will do?
Reject.
We will reject that as okay, this is not an unbiased coin, this is a biased coin. So what are we going to do? We say we will reject H naught. But what exactly is that? So it is actually an unbiased coin, but our outcome is outside A. So whatever the outcome we saw, it is outside A, and we ended up guessing it wrongly. So this is what? An error. So this is an error, right? So actual is different, our guessing is different, and there is an error between our actual and guessing. So that will raise up one type of error, which is type 1 error, where actually H naught is true. H naught is true matlab this is correct. So whatever the coin I gave you is an unbiased coin. But we ended up guessing it wrong. So by tossing it, we got head, tail, 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 and we reject H naught and say rejecting H naught means we are accepting alternative, saying that it is an. So we took an unbiased coin and tossed it up and ended up guessing it as biased coin. So that is what type 1 error means.
Then how can we find the probability of this, sir?
We can find the probability of this. I will do it. So this is nothing but we reject H naught given H naught is true. So given means it is known. This is known. So we know that H naught is true, but we ended up rejecting H naught by looking at the outcome of the outcome. So whatever the test, by looking at the test, we perform experiment we perform, and depending upon this particular test, we ended up guessing it wrong. So this is what type 1 error means.
So we will also need to find this.
We will also need to find
this level of significance.
See, usually the level of significance will be given to us.
Okay, so we don't have to find this.
More cases you don't need to find this. So depending upon the significance levels, see here we are interested to find which one is the good test, right?
Yes.
Good test and good acceptance set. So
Yes,
depending upon these alpha values and beta values, where beta we are going to see, depending upon these values, so which one is lesser you are going to get, then we will accept that. Accept it as good test or good acceptance set. Okay, by taking alpha, we will decide whether it is good or bad. Okay, sometimes when it comes to questions, we might ask you to find the significance alpha also. Okay, in both ways you can compute. I will show you how to compute also. But this is what type 1 error means. Type 1 error means, okay, simply if you wanted to connect with this real life scenario, see, let's say there is a machine that actually tests. So there is an test, or there is a machine which actually tests whether you have a disease or not, particular disease or not. Okay, so this is what the machine does. So when you sit in front of that particular machine, it scans you and it identifies whether you have that particular disease or not. Okay, so sometimes the machine may fail, right? After all, it is a machine. So if a person comes with disease and sits in front of the machine, but the machine fails to identify that the particular person has a disease or not, so that is actually a type 1 error. So it's actually true that that person has disease, but instead what we did, we rejected that, saying that this particular person does not have a disease. So this is what type 1 error is. So there
false
is another
negative,
type of,
na? False negative kind of.
yeah, even I will get confused sometimes. It is false negative or
false negative.
Yeah, negative means
Yeah.
It has disease, right?
The machine says it doesn't have disease. No, that is negative. Right?
Okay.
Which
Okay, true,
turns
false
out to be
versus
false.
negative, positive, right?
Yes.
And
Matrix will be.
okay. Another one is false positive. Correct? See,
Yes.
I don't want to bring that
Okay.
Understand it like this, okay? So your H0 is true, but you are ending up rejecting it. Okay, this is type 1 error. And what can be the other type? So just think about what can be the other type of error can happen.
Accepting H0, accepting H0 when HA is true. Acceptance is true.
Correct. So the other can be like H0 is false, but you are accepting H0. Okay, you can think it of like that. You can go there directly. If you, even though you forget, so you
In null hypothesis, but it is false.
Yeah. So you know null is false. Null is false means alternative is true. So HA is true.
What that hypothesis? What that called? Like this is called the other one was called level of significance, and what that is called?
That is called as beta. So that is that doesn't have any term, but 1 minus beta is called power. Okay. So that is size. That is about size, and size is very much related to probability of type 1 error. And there is one more test, one more metric, which is called power of a test. So power of a test is actually equal to 1 minus beta, where beta is actually probability of type 2 error. Okay.
Sir,
so what
could you please
exactly
write that, sir? Sir, could you please write that what we are discussing, like, alternate hypothesis? So type 2 error, we were discussing a type 2 error,
I
right?
will write it here. So what is type 2 error means? We accept H0
when it is false.
When HA is true.
Or we can say H0 is false.
H0 is false also.
Yes, yes.
If H0 is false means HA is true.
Correct. Okay?
Yes.
Sir,
So,
please repeat to understand.
So you see, yeah, when I take an example, you might understand. Okay. So what we did is I have given, but now right now I have given you a coin which is biased. So I gave you biased coin, but you ended up guessing it as unbiased coin. Okay. So what it is tells you is, what you did is, I gave you biased coin means your alternative is true here. So the alternative is biased coin. Alternative represents biased coin here. Our null represents unbiased coin. I gave you biased coin, that means alternative is true. But what you did is you did from some tests and you ended guessing it as unbiased coin. You just accepted H0. You just said it is an unbiased coin. So this is also an error, one type of error, one kind of error, and this is called as type 2 error. Okay, wherein, so if I wanted to bring up that disease example again, the person doesn't have the disease, but the machine ended up guessing it as that particular person has a disease. Okay, so that is also an error. So these are the two errors possible, where H0 is true, but you ended up rejecting H0. And the other type of error is HA is true, and you ended up accepting H0. So these are the two types of error, and beta is actually probability that accept H0 when HA is true. And you can also say one more thing here. So this is actually you reject alternative, correct?
When it is true.
When it is true. You can actually say this thing also.
When it is true.
Okay. And one more thing is the same thing. You accept H0 when H0 is false. So these all are same. Accepting H0 when H0 is false, accepting H naught when H naught HA sorry HA is true. You reject HA when HA is true. So usually we deal with accept H naught and reject H naught only. We don't talk about rejecting HA. So these two, accept H naught when H naught is false, or accept H naught when HA is true. Okay.
Yes, sir.
Now if beta is this, what will be 1 minus beta?
Sir, actually it's given as reject H naught when H naught is true, sir.
Actually,
so here actually the first one is to be reframed as like reject H naught when H naught is true, sir, right? That's what
that is what type 1 error is.
Yes, sir. So when we are listing it down, can you scroll down, sir? Type 2 error. Type 2 error is given as accept H naught when HA is true.
HA is true, yeah.
Yes, sir. That's all. So why the above one, sir? I didn't get the.
See, HA is true means H naught is false only, right? These are similar statements. H naught is false or HA is true. Both are same. Okay. But okay, you don't understand it in one way. It's better always. Okay. Now tell me this: if beta is probability of accepting H naught given HA is true, then what will be 1 minus beta?
A probability of accepting HA is true when HA is actually true.
Probability of accepting HA, or
that is 1 minus will be rejecting H0. That means accepting HA, no, sir? I mean, that's what
so
I
we don't either we do reject H naught.
Okay. Rejecting H naught when HA is true.
Correct. So is this correct? Everyone agree to this?
Yes, sir.
If beta is probability of accepting H naught when HA is true, 1 minus beta is probability of rejecting H naught when HA is true.
Just a small doubt, sir. Not doubt, just I am asking this doubt may come in future. Why HA is false we are not writing? Because we have changed the first statement, like here it is accept H0, H naught. We are writing reject H naught, right?
Okay.
And it is condition on HA is true. So here again we are using the same condition. Won't it change?
Sir, 1 minus beta is alpha, right?
1 minus beta is not alpha.
एक question complete होने दो यार आदित्य.
Okay. See this. So probability of A given B is beta. What is 1 minus beta?
I'm slightly confused here, sir, so I won't answer anything, sir.
Okay. So you have two sets A, B, okay? This is A, this is B. So what is probability of A given B?
Probability of A intersection B given probability of B. Yes.
Okay. So this is beta. So 1 minus beta is probability of B minus probability of A intersection B divided by probability of B. Okay.
Yes. Simply, yes, we have done the simplification. Yes.
Yes. So now look at this. You know law of total probability again.
Yes.
So probability of B, can I write it as probability of A? So probability of B given A times probability of A plus probability of B given A complement times probability of A complement. Can I?
Yes.
Yes.
Yes, right?
Yes.
Now you see this particular thing, I write it as, okay, I will just bring it down.
Take fresh space, it's a very good derivation.
Okay, so 1 minus beta. So what I gave you is probability of A given B is beta. So I am interested to find 1 minus beta, and I got probability of B minus probability of A intersection B divided by probability of B. Also I know that probability of B, I can write it as probability of B given A times probability of A plus probability of B given A complement times probability of A complement. Can I? Okay. So probability of B given A times probability of A minus plus probability of B given A complement times A complement minus. So what can I do with this P in?
That is the intersection part.
Can I write it like this?
You can write.
Huh?
Yes, we can write.
So P probability of A intersection B as probability of B given A times probability of A. Can I?
Yes, you can write that.
Right. So what is this thing now?
It's the complement part. Yes.
So what is this?
Okay.
Correct.
Okay.
So what exactly we got?
Yes.
If beta is probability of A given B, 1 minus beta will be probability of A complement given B.
So the conditional part remains the same.
Yeah.
So the conditional part remains the same.
Condition will remain same.
Got it, sir. Thank you.
It will be the complement.
This makes the difference, sir. Thank you, sir.
Okay. Yeah. So let me erase this thing.
Don't even, okay, fine.
Anyway, I wrote it down, right?
Yes, yes. No, we'll watch it again.
Okay. So yeah, this is what type 2 error is. So 1 minus beta is this. So depending upon this alpha and beta, so what we have to do is we can conclude which one is a good acceptance set. So this is the main thing we have to do.
So can we tabulate the whole things in a matrix? Type 1, type 2 error.
Which one in the matrix?
Type 1 and type 2 error in combination with HO and HA.
So you have wanted that 4 table.
Yeah.
Okay. So you can write it like H0 is true, or you are accepting, or you are rejecting H0. Okay. And H0 is true, H0 is false. Okay, this is how the table will be. So what it tells you, so there are four possible cases.
Yes.
So where H0 is true and you accept H0. So that means what it says?
That's a tick.
Yeah, that is true, right? That we don't even have any error, no error.
Yes, no.
Okay, because whatever I have, if I given you the unbiased coin, you guessed it correct and you said it is an unbiased coin. There is no error inside. And this thing, H0 is false. That means I have given you the biased coin. Instead, you have accepted it, saying that it is an unbiased coin. So this is type 2 error. Okay, wherein you accept H0, where H0 is false. That means HA is true. So this is a type 2 error. And you are rejecting H0, and you see this thing. You reject H0 where H0 is false. Even here also it is no error.
No error.
Correct. So your H naught is false means I have given you.
That's 1 minus b, right?
This one is 1 minus. No.
This no,
See
not
the
that, sir.
this one.
That one.
This one is type
1
2
minus
error.
b.
Yeah.
Is it 1 minus
How
b?
type 1 minus b?
Type 1 error.
Reject H naught. H naught is true.
So
Type 1 error, sir.
Not
Type
H
1.
A is true.
See, 1 minus beta is.
This will be, sir, 1 minus beta, I think.
So this is rejecting H naught where HA is true, not H naught.
Okay, yes, sir.
Okay, this is alternative is true. You are rejecting H naught when HA is true.
It means last one, sir, 1 minus beta.
So we got to bring HA also in the table. We got to bring HA also in the table, sir. Then only we can put the.
Then you can put 1 minus beta.
Yes.
Or okay, you are saying
how
in
no
this way. Okay.
That will be also 1 minus beta, na, sir. This last one. Because H naught is false, it means H A is true.
Okay. You are coming. Okay, correct. So you are rejecting H naught when H naught is false.
It means H A is true.
Correct. So this is 1 minus beta. Okay, but looking at the error, I am talking about the error. So there is no kind of error. H naught is false, and you are guessing that it is, you are rejecting H naught. There will not be any error, right?
Yeah, that's right.
So this is type 1 and this will be type 2. Okay.
Yeah. Okay.
What is this table called?
We got a name.
ANOVA table.
So it's called confusion matrix.
Confusion matrix.
Confusion matrix.
ANOVA, I think it is bigger table, right? More than, not only this. ANOVA is something, it deals with probabilities, I guess.
What is the name of the table, sir?
Confusion matrix.
Confusion matrix. Oh, that's very clear.
Yeah. Okay. So when you compute alpha and beta, our main goal is to keep this alpha and beta as low as possible. Both of them. So alpha and beta, you should try to get as low as possible. Yeah.
Sir, so actually 1 minus beta is called power and beta is called type 2 error, right?
Correct.
Beta is the probability of type 2 error.
Correct.
And 1 minus beta is the power, right?
Correct.
Okay.
So this is type 2 error. And this is type 1 error.
Probability of type 1 and type 2 errors.
Yeah. Probability of type 1 error, probability of type 2 error. So error we wanted to reduce. We generally would like to reduce the error, right? So therefore alpha and beta should be as low as possible for a good acceptance set here. Okay. So we will try to compute few alphas and maybe we can end it here. So in the next lecture we can discuss after that. So I will try to compute. So I will take this coin toss experiment and I will take few acceptance sets, different acceptance sets. And for different acceptance sets, we will try to compute alpha and beta. And among those acceptance sets, we will try to figure out which one is a good acceptance set. Okay. So yeah, the same example. Our null is unbiased coin and alternative is a biased coin where probability of head is 0.6. I toss the coin 4 times. So let me take some. Okay, before that, let us write the sample space. So which is head, tail, head, tail, head. Okay, there will be 16, right? Okay, like this. It will go tail. So I'm not writing everything, but you understand, you know what all the 16 outcomes are, right? Okay, let us start with a very simple one, even professor has used. So what if my acceptance set is 5? So now you can relate what is an acceptance set is, right? So if my acceptance set is 5, what this denotes? What actually this denotes?
It's a bias coin.
Rejecting everything. Like,
Yes,
yeah.
rejecting everything.
So what is the test here? So looking at the acceptance set, we can actually write the test. What is the test here? Test is we reject H0
and accept
every time.
HA.
And accept H0, HA.
yeah.
Okay, this is the test. Okay, for this we try to compute alpha. So what is alpha? Probability of you reject H0 given H0 is true.
Yeah.
Correct? So what is the probability that rejecting H0?
1 it should be.
So we always reject H0. Whatever it is, we are anyway ready to reject it. So what will be the probability? It will be 1. So there is no, it doesn't depend on the condition at all. Whether H0 is true or false, or we don't need, we are anyway going to reject it. So it will be 1. And what is the probability that, what is the beta? Probability that we accept H0
0
given HA is true. So what is the probability of accepting H0? So is there any probability of accepting H0?
0. We are rejecting everything.
0. We are rejecting everything. So here in this particular case, alpha is 1 and beta is 0. Okay, we got 2 values. And there is one more case which is all the things. So I will accept everything. So what is the test here? Corresponding test here?
H0 every time. Accept H0 every time.
Yeah, accept H0 every time.
H0, right.
Okay. So in this case, if you compute, alpha will be 0 and beta will be 1. So here you can see, when we will reject H0 in this particular case, probability of rejecting H0
0. We are never
probability
rejecting.
of accepting H0 is 1. Now from here it will change. Okay, maybe if we take other than these two, if I take, I have 2 to the power 16 subsets, right? These are only 2 of it. So I can take, so I will accept.
Sir, if we calculate 1 minus beta in both the cases, so in first cases beta will be 1 and second case 0, right?
Yeah.
So what does it signify?
What will it signify?
Significance is 0. Significance is 1, sir.
See, in this particular case, the size of this test is actually 1, which is actually very bad value for alpha. Very, very bad value for alpha. So you are just
okay, sir. What I will say, let us discuss other cases, sir. Then once again I will come back to this.
See, this is actually you are rejecting H0 when H0 is true.
Okay. Calculation is clear, sir. Calculation is clear.
Not about the calculation. Understand the situation.
Yes, yes.
So when your null hypothesis is true and you are rejecting that null hypothesis and it has probability of rejecting null hypothesis is 1.
Yes.
So can you imagine the particular experiment you are performing or the test you are looking at? Okay, probability of rejecting H0 is actually 1, which is very, very, very bad. That means I will always reject. Okay.
So beta value is coming 1, right?
Beta value is 1
coming
minus beta
1.
value.
1, sorry, 1 beta is 0, so 1 minus beta is coming 1.
So
right?
the power, the power of this particular test is actually 1.
Yeah, the power of test is 1, but I know that this is a very bad test, right? Because we are rejecting every time.
Yeah. See,
so can we conclude that if power is high, then there is something wrong in the test?
No, not about the power. So your power should be high. Okay. See, 1 minus beta is 1 is okay, good. But with corresponding to that 1 minus beta value 1, your alpha value is also 1. Okay. You have to combinely look at alpha and beta. Okay.
Okay. They can't be treated in isolation.
Yeah. So it's like if you have one value very less and the other value is very high, you cannot conclude anything. Okay. Relatively, you should keep both the values very less. Understood? Both the errors you should keep less. So this particular error chance is 100% error chance. What is this one represents? There is a 100% chance of having this particular error.
Type 1 error, yes.
Type 1 error. And that is very, very bad for some any experiment.
And power is also 1.
Power is also 1.
Sir, 1 minus beta, it means that we are accepting alternative hypothesis if it is true.
1 minus
1 minus beta
1 minus beta
is always 1 when we will accept alternative hypothesis.
When we are accepting null hypothesis means
suppose we will reject H naught and accept HA.
Okay.
Then 1 minus beta will be 1 always.
Yes. No, not always.
Not always.
How, sir?
See, I will take an example and I will show you. So now, other than those two, my acceptance set is somewhat like this. Only these 4. Okay. Out of those 16 possible outcomes, I have taken my acceptance set as if only I see this output or outcomes, these outcomes, any one of the outcomes, then only I will accept my null. So this is what acceptance set is. So what is the test here? We reject H naught. This is what the test is.
Yes.
So what we do, if I see anything outside of this acceptance set, any outcome coming outside of this acceptance set, we will reject H naught. Okay. Now we try to compute alpha. So this is probability of type 1 error, right? Which is probability that you reject H naught where H naught is true. So H naught is true means probability of head is 0.5. Correct? Correct? So H naught is true. What is H naught?
0.5. 0.5.
Unbiased coin. Unbiased coin has probability of heads as
0.5.
0.5. Okay. So when will I reject H naught?
When it is a part of AC, A complement.
If I have outcomes from A complement.
Yes.
So how many ways I can have?
12
ways.
12 ways.
Right. So 12 outcomes. For 12 outcomes, I will reject H naught. Correct?
Yes, sir.
And these 4 outcomes. So if my outcome is any one of these 4, I will accept H naught. Correct? This is the test I am doing. So I toss the coin 4 times. I see what is the order, and if it is in among these 12 outcomes, I will reject. If it is in this 4, I will accept. So whatever the coin I give, if it is unbiased or biased, I gave you the unbiased coin. So that is what it is given. I gave you the unbiased coin, But even if I gave you the unbiased coin, you took the test as like this. So your acceptance set is this, and the test is like this, and you perform the experiment. You toss the coin 4 times, and when will you reject? So if you see outside of this, so if your outcome is outside of this 4, among this 4, you will reject. So what is the probability that your rejection?
0.6.
So
12 by 16. 12 by 16.
Total, yeah. So it's like 12 by 16. So there are 12 ways you will reject your H0 out of 16 possible, total possible outcomes. There are 12 outcomes where you will reject H0.
Sir, intuitively it is clear, like there are 12 ways when I can reject H0, right? But if I go mathematically, so generally when it is P, A given B, then we write probability of A intersection B divided by probability of B, right? So can we use that formula here? Whenever it is given P, A given B, we write probability of A intersection B divided by probability of B.
Yeah, even you write that.
Yeah, intuitively it is clear, but through that way mathematically.
Okay, you can do that thing also. See, you are rejecting H0, okay? So what are, there are 12 ways, okay?
Yeah, so here the formula will become probability of reject H0 intersection.
Yeah, so intersection probability of head is 0.5 is something like you should take for head 0.5 and for tail you should take 0.5.
Correct.
Okay. So when will you, so you are rejecting H0, there are 12 possible cases. So one possible case is something like head, 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 head. Okay. What is the probability of getting this particular
1 by 16.
outcome?
1 by 16.
Yeah, correct. So 0.5 whole to the power 4. Correct.
Yes, correct.
So whatever the outcome is, it has chance 0.5 to the power 4. So even you can see it is.
Oh, okay, got it.
Huh?
Got it.
Correct. So what? So this is like an uniform. So every outcome has equal chance, equal probability with 0.5 to the power 4.
And in denominator again we will divide by 0.5, right?
No need to divide.
No, but if I go simply a formula, then it is probability of A intersection B divided by probability of B, right? Whenever conditional.
What is probability of B means? Probability of head is 0.5.
Yes, so that comes
that
in denominator, na sir.
See,
Can you please write down that conditional formula, sir?
Okay. If I
A
write
given
it,
B.
You are coming there. See,
Yeah.
Probability of head is equals to 0.5 is the event here. Okay, that is the event.
Okay. I was coming from that formula, sir. Can you write down that formula?
If I write it like this, it will be like this. Probability of you reject H0 is one event. Intersection probability of head is 0.5 is another event. Divided by probability of head is 0.5.
Yes.
Okay. What is the probability of head is 0.5? Anyway, you know H0 is true.
Okay.
So what is the probability of getting probability of head as 0.5?
4 by 16.
No. See, you know one event is true. Okay. One event is true. So what is the probability of happening that event?
1. Whenever it is true, then it 1. Yes.
So whenever it is true, it is 1.
Yes.
So here probability of head is 0.5 is true. So what is the probability of
Okay.
Okay. Yes.
Okay, you won't have this.
Yes.
You won't have this.
Okay, so the intersection part will also vanish, right?
So you will have probability of rejection cases where your probability of having head is 0.5.
Okay, so only 12 by 16 comes, right?
Like you will have 12 times of 0.5 to the power 4. Correct, right? You have 12 cases, and each of the case you have probability of 0.5 to the power 4.
Got it.
So this will be like 12 times 1 by
Yes,
2 to the power
6.
4. So this will
Yes.
be like 3 by
12
4.
by 60. Yes.
3 by 4, which is 0.75.
So here we are treating that as 1 because probability of head equal to 0.5 is 1, right?
That is a true thing. Yeah.
Yes, yes, yes. Got it. Thank you, sir.
Okay.
Thank
So okay, maybe alpha we got. So similarly we can compute beta. What is beta? You have type 2 error. Okay. So what is this? Probability of we accept H naught given alternative is true. Hello? Am I
Yes,
audible?
sir. Yes, sir. Yes, sir. Very much audible.
Okay. Now tell me, alternative is true means the probability that you accept H naught when probability of head is 0.6.
Yes.
Okay. So when will we accept H naught? So when are we going to accept H naught?
That will be 4 by 16. Na, sir?
All times.
Yeah. So these are the 4 possible outcomes. If my
Yes.
outcome is one of these 4 possible ways, then I will accept H naught. So this is simply probability of head, like those 4 things. Probability of head, tail, head, tail. Okay. Head, tail, head. So like this, probability of
Head, tail. Okay, sorry.
What is that? Head.
4 times tails.
Tail, head. Yeah. Tail, head.
And 4 times tails.
Plus 4 times tails.
Yes.
So what is the probability of head, tail? When probability of head
1
is
by 16.
No, when probability.
Okay, no, it is not 1 by 16. Sorry, it is not 1 by 16. So 0.6 to the power 2 into 0.4 to the power 2. Yes.
How this happens, sir? Can you once do this? How this happens? Can you once again do this?
See, when are we going to accept H naught? When my outcome
Will be from set.
Will be from this acceptance set.
From the acceptance set.
And I have given you the biased coin. Okay, HA is true.
Okay, yes.
Okay, when I have given you the biased coin, probability of head is 0.6.
Okay, yes, sir.
Correct?
Yes.
So when I toss a coin, probability of getting head, tail. So what is the probability of getting head, tail? When the coin is a biased coin with probability of head is 0.6.
Okay. Yes, sir.
So it is something like for getting head it will be 0.6 and getting head it will be 0.6, 0.4 and 0.4. So 0.6 times 0.6 times 0.4 times 0.4. Agree?
Okay, yes, sir. Yes, sir.
So that is what it is.
Okay.
So similarly, this is one. So probability of getting this particular outcome is this. So similarly, I can have 4 ways where I will accept H naught. Correct, right? If my outcome is this or this or this or this, I will accept H naught.
Yes, sir.
Yeah. So for getting this particular outcome, I have this much probability.
Yes, sir.
And for getting this much probability, and this much probability, and this much probability. And what are we doing? So if I am getting this output, what am I guessing? I am saying that this is an unbiased coin.
Yes.
Correct?
Yes.
But instead what it is actually a biased coin.
Yes.
So that is an error. So these are the 4 ways we can do error.
Yes.
These are the only possible 4 ways which we do error. And that is what the type 2 error probability is.
Correct.
Okay. So this is 0.6 whole square, 0.4 whole square. And finally the last one is 0.4 whole to the power 4. So getting all tails is difficult, very difficult. It has very less probability when the coin is a biased coin. Agree
So,
or not?
yeah, it could be possible that the coin is biased in the side of tail.
But here what is our alternate hypothesis? Our probability of head is, so our biased coin has high chance of getting head.
Okay.
Okay.
Okay. Okay.
Yeah. So this is what the type 2 error is. If we compute, we will get some value. So this will be beta. Okay. I have beta value and I have alpha value, which is 0.75. So let me give you one more thing. Let us do one more thing. So if I have given acceptance set as
sir, it is 0.1984 for this case, sir. 0.1984. We can write it down. Yes.
0.1984, is it?
Yes. Yes.
Okay. So this is one more. Okay. And yeah.
HS, 4H.
No, HS, I will try to reject H0. See, usually logically, if I get 4 heads, I will say it is a biased coin. Even 4 tails also, I don't want to take. Okay, let us take this only. So if I see, so what is the test for this?
Alpha.
So what is the test? So I have the acceptance set with me. So corresponding to this acceptance set, what is the test I'm going to test? What is the testing I'm going to do? When am I going to reject H0?
If it is biased.
Unbiased coin.
See, reject H0.
If it is not in A.
Which is not in A. So if I will reject H0. If there are more heads or more tails. So just look and say whether this is a test I am doing or not. So what am I going to do? I am going to reject H0. If I see heads, either heads or tails more, it should be equal. If it is equal, I accept.
Okay.
So that is what I'm doing. This is my acceptance set, and whatever the outcome I see, my heads and tails are equal in my outcome, in my acceptance set. So if I can also say this, if number of heads is not equal to number of tails. Okay. Is this the test I am doing? I reject H0. That means I say this particular
Head tail is greater than 2. If head tail is greater than 2.
Yeah.
Yes, sir. When they are not equal, number of heads and number of
Or
tails
not equal, if head tail is not equals to 2.
So if I see anything different combination, what I think is it is somewhat biased. Okay, understood this acceptance set and test now?
Yes.
So let us compute alpha for this. Okay, so it is actually probability that reject H0 when null is true. So when am I going to reject H0? When
it is not part of this set.
Yeah, so that
10 cases
A
are
complement.
there. 10 cases. Yeah, 10 cases are there.
A complement given probability of head is 0.5.
0.5.
So there are 10 cases, and when it is 0.5, you can understand every outcome has equal probability. Okay, when probability of head is 0.5, whether it is tail or head, it is 0.5. For 4 coin tosses, it will be like 0.5 into 0.5 into 0.5 into 0.5. So I have in my acceptance set six outcomes. So the rejectance set will have 10 outcomes. So the probability of that A complement set will be 10 times of 0.5 all to the power 4. Correct? Wrong?
10 by 16.
Correct, right?
Sir.
This is correct?
Correct, sir. Yes, sir.
Okay, there are 10 outcomes where I reject H0. And each of the outcome will have probability of 0.5 to the power 4. So this will be like 10 by 16. And my alpha value is somewhere around 5 by 8 and it will be like 0.625. Okay. And what is the beta value? Probability that I accept H0 given HA is true. So when HA is true, so it's like probability of
Probability is 0.6.
Probability of head is 0.6. So how many I have? I have
Two and two heads, two tails.
2 heads and 2 tails. So each of them will have probability of
0.6 square, 0.4 square multiplied by 6.
Correct. And each of them will have this much probability, and there are 6 outcomes like that. So it will be 6 times
3, 4, 5, 6 are final answers.
So what is the value?
0.3456. Very interesting.
Okay. Yeah.
Yes.
So now we have done 4
0.3456.
different. Yeah. Now we have taken 4 different acceptance sets and 4 different tests, and we have computed alpha, beta for everything. Let us put it together and let's see. So this is alpha, this is beta. So test 1 maybe, test 2, test 3, test 4. So here my acceptance set is 5 and the next acceptance set is all, and we have few acceptance sets here. Okay, so just go up and see. We have done 4 tests till now. And what are the values we got? What are the values alpha and beta?
So alpha was 1 in first case, and then beta was 0.
And here?
And it was reverse 0 and 1. And I think it was 12 by 16. 12 by 16. And this was 10 by 16.
So beta is something 0.1984.
We have written it down. So you have written it down. Yeah.
Okay.
Can you scroll it?
And this is 0.625 and this is 0.3456. Now you see, if I change the test and the acceptance set, my alpha and beta values are changing, right? Depending upon the test and the test and the acceptance set, my alpha value and beta value.
Can we add one more row for 1 minus beta, sir? Can we add one more row for 1 minus beta power?
See, 1 minus beta is nothing, no? 1 minus of these values.
Okay.
So what will you get? The same thing. Nothing. If you have beta or 1 minus beta, it doesn't matter. But more,
I just want to understand the significance.
See, our more focus should be on our more focus should be on this alpha and beta.
Okay.
And we want collectively you should reduce both the values. Okay, both of them should be low. Okay, if I take 1 minus beta, there what happens, there your alpha should be less and 1 minus beta should be more. So that is something like 2 opposite directions. We cannot compare. Understand? Hello?
Yes, sir. Yes, got it. Am I audible, sir?
Yeah, you are audible. Okay, now
Then
you
what
see.
is the conclusion of this table?
Yeah. What is the conclusion of this table? You tell me. Which one is a better test?
So I guess T4.
T4, sir.
T4. Why? Like why?
Because both the values are like, because in case of T1 and T2, one of the value is 1, which is very high. In case of T3, alpha is high and beta is low. But in case case of T4, both are like moderate kind of thing comparatively.
Yes. So even this is also not the best one. But among these 4, so if I wanted to compare among these 4 only, so you see there is a 100% chance of having one error in this first case, and which is actually a bad one. So if there is a 100% chance of going failure, we don't even start that we don't even use that machine, right?
Right.
Either one of it. So if alpha and beta I should keep low. Beta I kept it low. Beta is 0, which is very good thing actually. But by keeping beta 0, what I did is I made 100% error in the type 1 error. There is a 100% chance of getting error in this type 1. There is a chance of 100% for type 1 error, and we don't want that. So at least there should be some chance of guessing correct, right? Guessing should be correct. So somewhere or sometime you feel, right, I shouldn't go error, I should be error free. So based on this, as our alpha and beta should be low enough comparatively. It's not like one is low, so you should take that. So comparing both of them should be predominantly low. So if you see that, so even this is high, even this is high. So when I compare between these 4, T4 looks somewhat moderate kind of thing, like there is a chance of 30% for type 2 error and 62% for type 1 error. Even this is high. I don't say this is the best one, but among these 4, this T4 is better. So you can take something like T5, test 5, wherein you can actually take some 8 elements in the acceptance set and leave out some 8 elements. Then you will get a better alpha and beta values.
So does that mean we should always take the mean of alpha and beta and check the lowest value?
No. Not the mean and everything.
Okay.
Okay. So this will be like you fix alpha as that is a significance level. That is why it is named as significance level. So what we actually in the problems also we do is we restrict our alpha, what should be our alpha is. So whether the significance level. So how much error I can go. So maybe some 5%. Or maybe some 6%, or maybe if I wanted to be, if I wanted my machine to be very accurate, I will go for 2% of error. Probability of happening type 1 error, I will reduce it as much as I wanted. So I wanted to improvise my machine in such a way, right? So by fixing alpha, I will try to bring the least value for beta.
Okay.
Okay. Yeah. Okay. So this is, I guess this is about the size and power of the test. So what exactly we did is, this is called Neyman-Pearson paradigm of hypothesis testing. What we did is we took some samples of IIDX, so some n samples of IIDX, and we defined a null hypothesis and an alternative hypothesis, and we defined a test also, and this test comes from an acceptance set A. So above also we did some 4 tests, and all the 4 tests has some acceptance set A. So if the sample falls in A, we accept H0, otherwise we rejected H0. So that is what we did. And by doing this, we can have 2 types of errors. One is type 1 error and another one is type 2 error, where type 1 error is you reject H0 when H0 is true, and type 2 error is you accept H0 when HA is true. Okay, so there are two types of errors can happen, and for choosing this acceptance set, better acceptance set, there are 2 metrics. One is significance level alpha, which is probability of type 1 error, and another one is power of a test, which is 1 minus beta, where beta is actually the type 2 error. So size and power of a test can be computed using this type 1 error and type 2 error. So where this type 1 error is probability of rejecting H0 when H0 is true. This is accepting H0 when HA is true. So this is what we did, and so there are some examples in the lecture 1.2, I guess. So even I wrote those all things. See, I am at 9th page. I have many more things, but due to time constraint, I can't deal it now. So maybe we will deal it in some other day.
You can continue, sir.
No, it's already 10:40. Okay.
Sir, you'll be uploading this document?
I will upload this document. Okay.
But I think on Tuesday there will be solve with us session.
Yeah, you have solve with us session. Maybe see, I can take tomorrow, Monday, anytime. No, not Monday.
Tomorrow.
Maybe, huh?
Tomorrow, sir.
Tomorrow is Monday, sir.
Tomorrow is Monday, but
Then Tuesday.
Tomorrow, what sessions do you have?
So this content will be available under supplementary content, sir, after you upload.
Huh?
Content, sir, where will be available?
There is a open session of Python 8 to 10.
So
it will be under supplementary content, sir.
Yeah, it will be under supplementary content. Wherever we upload general, whatever the documents we upload, there only we upload, right?
Sir, I lost the connection. I was just asking when you will come next time. Like on Tuesday we have lost, no, solve with us session.
Maybe I will be coming on next Friday, next session.
Sir, when you will continue this, like
I am just
That's the
searching
point.
for tomorrow. See, tomorrow 68 I have session.
Okay.
Maybe after 10, if you okay, I can take.
We are okay, sir. After 10.
So maybe for 1 hour I will just take. I guess you have an on-demand session, right? Do you have any on-demand session?
No.
No.
I have requested that you to conduct. You have not conducted so far.
Not, sir. It is not scheduled.
I will conduct.
Well, sir, after 1 week we will start.
No, I understand. See, even I should get time, right? So I'm
Sir,
getting
please
time
take. Sir, please take tomorrow and after 10 because
okay.
So most of us are surviving
just finish
because of
this.
will start too.
Okay.
Just finish
For
this.
this
Sir,
we are ready tomorrow.
See, that is
after 10 we are
that
ready.
is a big
You can
statement,
check with
right?
other people also.
Okay, there are only 21 people, right? I'm asking to everyone, can I continue for 2 more minutes or sorry, not 2 more minutes, 20 more minutes or something?
Okay, sir, you can continue.
Now continue.
Today you have
Today itself. Now. How many of you are ready now?
No, sir.
No, right?
Yes, sir. Everyone is.
I'm okay from my side.
Because
because sir, to be very frank, it was not at all clear from the videos this lecture.
Correct.
And it is so clear now after you explain it. So
see, even I try to spend more time because see, professor has to cover more number of topics in very short span. Okay,
that's true.
So he may not be covering each and everything like whatever the sample space I have denoted.
True.
So professor has said something like subscript x and subscript x to the power n, and you.
Yeah, even I got confused because I was thinking all the way it is power. So I was trying to understand how it is.
So yeah.
As Kavita rightly said, sir, we have so many questions and every doubt got clarified, sir.
Okay, so even I
we can
sometimes I
continue.
spend time on
Sir,
very
sir,
easy
it's
things.
it's already 2.5 hours.
Yeah, correct.
You can take half an hour tomorrow, sir.
I feel see there are examples only, and later I have something like what are the different types.
So sir, tomorrow can we complete the entire week? Tomorrow can we complete the entire week? Like,
I will try to see. That is why I'm preparing you, right? So be prepared. Like come at 10 p.m. So it may go till something like 11 or 11:30. So you should be
Yeah,
ready.
then
Yeah, tomorrow, right, sir?
Sir, tomorrow let's conclude this week, sir.
Okay,
Yes,
perfect.
that's
Tomorrow at 10 o'clock.
That's also okay, sir. Tomorrow let us
can
complete this.
Can you also look at doing it in the morning, sir? Early morning.
Look at the early in the morning.
I can't wake up, sir.
Sir, what about 4 o'clock to some 6 o'clock kind of thing? Wherein earlier our other your colleague has taken that kind of time. Please ask.
Sorry, not 4 o'clock, please. We're working.
भाई 8 बजे उठते हैं कम से कम मुश्किल से.
No, 4 o'clock in the evening is too early. Sorry, my day
Yeah,
doesn't.
so many of them
Yeah,
requested.
10 p.m. is fine.
10 is
sir.
okay.
10 PM is
Okay,
fine.
10 p.m. okay for all.
Yes,
Yes, sir.
yes, sir. Yes, sir. Okay, sir.
Okay.
Yeah,
So
okay, sir.
if you feel sleepy, you can sleep. I will upload
Hello.
the recording afterwards. Okay, tomorrow thing.
So we will cover that.
So on the same in the same link, right? This the same link of
Maybe
today?
last time I have posted. Have I taken stats to on demand anytime? No, right?
So how to get the link, sir?
No,
then?
sir.
How
Okay,
to
okay.
get the
It
link?
was in mathematics. So I will try for Zoom link. Okay. If I didn't get Zoom link, what I will do is I will create a Gmeet link and I will
Yes,
add
sir.
them to the calendar. I will ask them to add it into the calendar.
Okay, makes sense.
Okay.
And you can even send us in Telegram group.
Yeah. Okay. We have the Telegram group, right? I will
Sir,
just
what's the final decision, sir? What's the final decision? I don't know what is happening.
Tomorrow 10 p.m. we are going to meet and we will cover the rest of the.
Would you be sending a link for the class tomorrow?
Of course. I will tomorrow morning I will try for the Zoom link. If I got the Zoom link, I will just add it in the calendar.
And we'll complete the entire week, sir. Huh? Please.
I'm not a part of this Telegram group. Is there any way I can get it?
I'm also not a part of Telegram.
Yes, sir. The Telegram will be so WhatsApp, sir.
So can someone share the Telegram group in the chat?
सर टेलीग्राम ग्रुप नहीं है सर हमारे पास.
Ask someone to update calendars.
Okay,
Sir. That's the right way.
Yeah, that is the thing I will do. I will do both. Okay,
Yes,
I will post the
Many of us are not part of Telegram group.
Okay, sure. No worries.
Sir. Calendar will be the best.
Okay, I will do one thing. I will try for Zoom link tomorrow morning.
Okay, that's nice, sir. Thank you, sir.
So while we're taking tomorrow's class, we go through the one query I have. So first to see the markings. Sir has logged out one like the first lecture, so just we can touch on that. So, hello.
Sir, I think sir left.
Sir left.
No, sir is here.
Hello, sir.
Sir has lost the connection, I think.
Sir, yeah, sir left now.
Does anyone know how to send this link to Telegram link to others? So I would have sent it on this group at least in case.
Let us drop that idea. Many of us are not using Telegram.
Hello.
The Telegram
Okay.
is like so many messages and.
Yes, sir. You are back. You are back, sir.
Yeah. So I will do one thing. I will upload. I will update in the calendar only. Whether it is Gmeet or Zoom link. Okay, it may be any of it. I will try for a Zoom. If I didn't get Zoom.
Yeah, Zoom will be fine, sir.
If I didn't get Zoom, what I will do is I will create a Gmeet link.
Sir, are you there?
Hello. Hello.
Yes, please.
Yes,
sir.
sir.
Audible, sir.
Am I audible? Yeah. Okay, I will create a Gmeet link. I will share that Gmeet link in the Telegram group, as well as I will upload. I will update the calendar. So will this be okay?
Yes, sir. And timing is 10 o'clock, right? 10 p.m. right?
Yeah. After 10 p.m. Okay.
Okay,
Maybe
perfect.
just take a break after the Python session. We will meet at 10:15. Okay.
Perfect.
Okay. 10:15 and it may go till 11 or 11:15. Okay. See, usually what I feel is I will go slow. Okay. Even if one of you guys raise your hand, I never say no and I will just move forward. Okay, I want everyone to understand everything. So that is why I move very slow. I'm like tortoise. So I don't
So
know
our
how
aim will
long
be,
it will go.
so our aim will be to complete the entire week, right?
Huh?
Our aim should be to complete the entire week tomorrow, week 11, right?
Okay, yeah, that is
Yes,
what
yes.
I said, right? So what I say
Yes,
is, you come prepared that maybe next 1 hour or 1.5 hour, and
yeah, that's fine, sir. Once it starts, that's fine.
Yeah, that's fine, sir.
Okay,
that's fine.
Okay.
Just one question. The Gmeet thing also you will be sending over the calendar, right? Even if this is Gmeet.
Yeah. That is what I
Okay.
said.
Yeah, thank you.
Whatever it is, I will update the calendar, and as well as I will post it in the Telegram.
Yep. Thank you. Thank you. That's it.
And we will have the recording also. Right?
Okay. Maybe in the next session, Ganga Prasad. So you have asked me something in private.
Yes, sir.
Okay. So maybe in the next section I will. Okay.
Then just one more thing,
Okay,
sir.
sir. Okay.
So one thing, one more thing, sir. So tomorrow session before we go on to the other sections in the week. So just the first video itself, that one working which was not clear, sir, especially in the video. So we'll just quickly see that and then.
Okay. I will just ask.
Just a request, sir.
Okay. Karthik, just stop the streaming now. You just stop the streaming. Host, you just stop the streaming of stats too.
Thank you very much, sir. Thanks for.
Thank you and good night.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you, sir. Have a good day.
Have a
Thanks.
good night. Meet you tomorrow.
Thank you, sir.
Okay, sir. Thank you, sir. Good night, sir.
Yeah. Good night.
Thank you, sir. Good night.
Good night. So you are going to give me the timestamp, right? Is that what? Hello?
Hello?
Yes, sir. Correct.
Yeah, someone asked me one question.
Yes, sir. When we start tomorrow, I'll just that particular timestamp of the video as you're saying.
Acha. Particular timestamp.
Yes, sir. That video, there's a mark working. The professor are showing some work.
Okay. So
it was so concise that I didn't understand like how these steps were, how the formula worked out to that.
Okay, got it. You wanted me the timestamp of all this particular.
No, I'll just maybe part it out which timestamp and then we can do.
Okay, sure. Okay.
Just a few